Okay, so we've been talking about interior angles. Now what about exterior angles? We've talked about exterior angles with triangles before. If you extend one of the sides, the angle that's formed by that side that you just extended and one of the other sides, so this angle right here, that would be an exterior angle. So let's do some exploring. Let's say these are all regular polygons. So we just learned that in a regular polygon, all the angles are congruent. And if this is a regular pentagon, each of those angles, interior angles, is 108 degrees. We just talked about that. So these are all 108 degrees. So, blast from the past, this interior angle and this exterior angle form a linear pair. This interior angle and this exterior angle form a linear pair. They're supplementary. They add up to 180 degrees. So I can figure out the measure of this exterior angle by subtracting my interior angle from 180. So this exterior angle is 72 degrees. So that means all of these are going to be 72 degrees since they're all 180 and 180, sorry, they're all 108 and 180 minus 108 will not change. So that's an important concept. If your polygon's regular, not only are all of its interior angles going to be congruent, but all of its exterior angles are also going to be congruent. If all 5 of those angles are 72, and I add them all up, I have 72 degrees for each angle, and I have 5 angles, 5 of those exterior angles. They add up to 360. Interesting. Okay, let's do this hexagon. So in each hexagon, all the angles add up to 720. And so if I divide that by 6, each angle is 120 if it's regular. So that means that these interior angles form linear pairs with these exterior angles. So 180 minus 120, these are all going to be 60 degrees. So each of my exterior angles is 60 degrees. And I have 6 of them. Well, 60 times 6 is 360. That's interesting. Okay, this is 1, 2, 3, 4, 5, 6, 7, 8-sided polygon, an octagon. And each interior angle of a regular octagon is 135. I'm going to save myself some time and not do all of them. So each interior angle is 135. So that means each exterior angle is 180 minus 135, which is 45. So each exterior angle of a regular octagon is 45 degrees. And if I have 8 of them, because I have 8 interior angles, that means I'm going to have 8 exterior angles. 45 times 8 is, I wonder what it's going to be. 45 times 8 is also 360. The moral of this story is no matter how many sides your polygon has, and no matter if it's regular or irregular. So these were all regular, but this is true of all polygons. If you add up all of the exterior angles, the sum of the exterior angles of every polygon that has ever existed will always be 360 degrees. So the sum of the exterior angles touchscreen problems. Exterior angles of every polygon is going to be 360 degrees. So if you add up all of the exterior angles of every polygon, whether it's regular or irregular, if you add up all the exterior angles, they always add up to 360, no matter what. So we have this this chart is something that you're going to want to have memorized. It is super helpful. It helps you pick out the keywords and help you determine what formula you should use. So we've talked about this. N represents the number of sides or the number of angles. So the sum of the interior angles of every polygon, whether it's regular or irregular, remember you take the number of sides, which is n, subtract 2. That gave you the number of triangles, and then remember each triangle has 180 degrees. So you're taking the number of triangles, n minus 2, multiplying it by 180. And then we talked about how, okay, if you know the total, this is like the total number of degrees, the total number of degrees in all the interior angles, the sum of the interior angles. If you take the total and you have a regular polygon where all of the angles are going to be congruent, if you're trying to find the measure of just one of those individual angles, you're going to take the total and divide it by the number of angles, which is n. So that's for interior angles. So this top row is for interior angles. Okay, we just learned from our little exploration that the sum of the exterior angles, if you add up all the exterior angles of a polygon, no matter what, if it's regular or irregular, it's always going to be 360 degrees. No matter what, always 360 degrees. So if the total is always going to be 360 degrees, well, how are we going to figure out the measure of just one individual angle? Well, if there's 360 degrees total in of all these exterior angles in this pentagon, and I take 360 and divide it by 5, the number of exterior angles, that's going to give me the measure of each individual exterior angle. So it's a very similar concept like to finding each individual interior angle for a regular polygon. If you take the total and divide it by the number of angles, it's going to give you the measure of each individual angle of a regular polygon. So if I'm trying to find the measure of each individual exterior angle of a regular polygon, I'm going to take the total, which is 360, and divide it by the number of angles. So this chart is really helpful. Like the top row has to do with only interior angles. The bottom row has to do with exterior angles. This left column is about the sum of all those angles, and this right column is only applying to regular polygons. So if you're using the word regular, you're probably looking in this column, and it's to help you find the measure of one individual angle of a regular polygon. Then if you notice, if you know this formula in the left column, in the sum column, to find the measure of just one of those angles in a regular polygon, you're just going to divide it by n. If you know the sum, you're just going to divide it by n, and that's going to give you the measure of one of those individual angles. So this looks really complicated, but really all you are doing is taking the formula on the left and dividing it by n to get the measure of just one. You're taking the total and dividing it by the number of angles to get the measure of each individual angle in a regular polygon.